G'day everybody, where's Wally here? Hey, welcome to Flatzoid's 11, episode 4. The derp just keeps coming.
It's got to be this size ball. It's got to be this.
If it's not flat, then it's not flat, though.
Yeah, but if it's got to be this size diameter, not a different diameter, so it's got to be this diameter, not a different diameter.
Yeah, and we showed your damn terrestrial refraction changes the actual geometry of the globe. It doesn't have anything to do with light refraction. It literally changes the radius of your globe.
Literally? Seriously, Flatzoid? I think you literally do not know what literally means.
Uh-oh. So your globe breathes, in other words.
Oh, I stand corrected. He does know exactly what literally means. He's used it correctly and made his derp, figuratively millions of times worse. Oh my goodness. So, Flatzoid believes that the globe breathes. You mean literally changing size. Well, I guess that is a strawman of global proportions, literally. So now you're failing on terrestrial refraction as well. Now, you do not need to have an interface to bend light in one instant. You can have a density gradient that will just really gently massage and curve the light into a slightly different direction. So Flatzoid, here is a scientific experiment, yes, I said scientific and experiment, that I did for Anthony Riley. And it must have been pretty good because he blocked me immediately after and will never talk to me again. So it must have been perfectly undebunkable. I hope you enjoy it. Okay, so your null hypothesis and your alternative hypothesis. The null hypothesis is that the laser light in a sugar-based density gradient tank visibly bends due to the dextrorotation nature of the sucrose used in the density gradient solution. The alternative hypothesis is that the observed bending of the laser light is solely due to the density gradient of the solution, not the rotation.
Do a video and tell me how I'm wrong.
So I weighed 40 grams of salt and put it in 200 grams of tap water, placed them in a pan and heated them to a simmer. I filtered the solution through a standard coffee filter to remove the sediment, made it nice and clear. I allowed the solution to cool and then I added 1 drop of green dye. Don't use red dye or blue because that will block the green laser light and you won't be able to see squat. Now for a light box I use the 16-pack Ferrero Rocher. And what you do is you open the box, give the 16 to your significant other so you don't end up with a situation like this.
The solar system was stationary.
Alright, honey, come on.
The sun was standing.
Why don't you stop this bullshit?
Idiot. Shouldn't you give me like 5 minutes?
No, you've had it all morning.
So I put 500 grams of tap water into the light box, thanks to Ferrero Rocher, and then I measured the TDS of the tap water, which gave me around 32 parts per million. So at the top level of the tank, the reading was just under 100 parts per million. And when it went as steep as I could get it, it was well over 1,000 parts per million. So there you go, we have a density gradient in the salt confirmed. So I decided the best way to demonstrate the effect is using a density gradient and a time lapse. So I let the concentrated salt solution run slowly from the glass via a tiny tube in a siphon and took a photo every 10 seconds with the GoPro on time-lapse mode. And this is what I got. And I'll zoom in a bit and play it again for you as well. Then it was time to introduce the homogenator. And just look what happens with that laser light. All of a sudden, it goes straight again. Because you see that screw, the laser beam was bending down and touching it before the homogenator did its job, and now it's going straight over the top of the screw. And I guess that glare coming off the screw is probably why the photo was a bit washed out in the first place. So all I did was twiddle the gradient. I changed it. I changed it from being a strong gradient to being a non-existent gradient, all with the use of the homogenator. And as we can all see, the bending of the light is totally dependent on the density gradient. So the null hypothesis is not upheld. The alternative hypothesis does hold. So now we understand that the light is curving due to a density gradient, and that gradient is not in any way to do with polarization because the solution never changes. We can now see that Snæfell is in a different position to what the theoretical geometric atmosphereless Earth would be, and that's due to the atmosphere not being homogeneous. There is a gradient in the atmosphere. Thank you, Tony. Now the problem for you, Tony, is that everything you've just made is all going to unwind. So now you have to go back and revisit again because nothing to do with polarization is in play here. There's only a gradient. Thank you very much, Anthony. So how was that, Anthony? That was all too easy. Barely an inconvenience. Bit of salt, bit of water, put it in carefully, shine a laser beam through it, light bends. Mix it up, light bending goes away. All too easy. Okay, so if you like that, how about you click and share and subscribe and be the first to get in on the next fun little adventure into destroying the flat Earth. Now, while you're doing that, I'm going to literally destroy this little thing here. So I sends my data, my experiment to Conspiracy Cats just to do a peer review, and what does he do? Oh, not enough data points. Reject the outliers. Grade it on a normal curve. Come on, use the right Q test. Man, this guy... Now take that, would you? Now see, you guys, do you see? Do you see? Oh man, do you see, mate? Do you see? Goodness me. Take that. Okay, have that. How do you like them apples? Well, how about that, guys? That was fun. Thanks, guys. Sorry, Flatzoid, you fail yet again.